Hey everyone, welcome to this episode of Anderson Productions. Today we're going to be exploring absolute value equations. Before we begin, make sure you have the following materials out: a pencil, a pen for corrections, and a copy of today's class notes. Are you ready? Alright, let's begin. Today's goal is all about solving absolute value equations. By the end of today's class, you should be able to extend your knowledge of absolute value in order to solve absolute value equations. You should be able to identify equations that have two solutions, extraneous solutions, and situations in which there are no solutions. All right, let's get rolling. So before we begin absolute value equations, it's really important we understand what is absolute value. So by definition, remember, absolute value is a number's distance away from zero. And when we talk about distance, distance can never be negative. So let's take a look at some of these examples here on the bottom. We read this as the absolute value of 5, and we're going to ask ourselves, how far away is the number 5 from 0? Well, we know that's 5 units. Let's take a look here. We read this as the absolute value of -9 is, that's correct, 9. The absolute value of 0, well, if we think about that on the number line, 0 is how many units away from 0? That's correct, 0. So then we look at the examples on the bottom. We've got the negative absolute value of 8. So when I'm thinking about this problem, I first look at what is the absolute value of 8, which is, correct, 8, and then we just tag that negative on. Now some may argue and say, well, I thought you just said absolute value cannot be negative. Well, remember, in this case, the absolute value isn't negative. We're just tagging that negative back onto the bottom. Let's look at the next example. We've got -2 times the absolute value of -10. Remembering that when we look at this problem, there's that imaginary multiplication sign. So when we simplify this out, we have -2 times, and we ask ourselves, what is the absolute value of -10? Good, 10. And we get -2 times 10 gives me -20. And then our last example, when we're looking at absolute value, is something like this, where we have a numerical expression inside the absolute value signs. And a problem like that, it just goes back to order of operations. We first simplify inside the absolute value. What's -9 plus 3? Good, -6. We bring down those absolute value signs, and then we ask ourselves, what is the absolute value of -6? 6. Good. So now we have a good idea of not only what absolute value is, but also how we can approach absolute value expressions when dealing with numerical expressions. But remember, that's not today's goal. Today's goal is all about absolute value equations. So, going back to this idea of an equation, remember, an equation, we're typically solving for a variable. We're asking ourselves what value of x will make that equation true. So in each of these examples here, I'm giving you guys 4 different equations, and I'm asking what value of x would make that equation true. And as we're going through each of the problems, we're going to think, is there more than one solution? Remember, sometimes thinking, is there one solution? Maybe 2 solutions, maybe no solutions, or infinitely many solutions. So we first look at this example here. The absolute value of x equals 4. Now I can think about this in 2 different ways. I can think about what number has a distance away from 0 of 4 units. And the other way I can think about it is, okay, what value can I place inside those absolute value signs that would result in 4? Think you have an idea? Good. In this case, x can equal 4 or x can equal -4. We know those are the 2 different values that result in an absolute value of 4, or a distance away from 4. So I can write my answer like this, positive or -4. Let's look at the next one. The absolute value of m is equal to 0. Once again, I can ask myself what number has a distance away from 0 of 0. Or I can ask myself what value can go inside those absolute value signs that will result in 0. And in this case, there's only one solution, m equals 0. This one has 2 solutions. The other way you can write this, by the way, is -4, 4 in braces, saying it's the set of values, -4 and 4. All right, so let's look here. The absolute value of w is equal to -3. Once again, the 2 different ways that we can think about this problem, right? We can say, all right, what number can go inside those absolute value signs that will result in an absolute value of -3? Or I can think about it more logically, like what number has a distance of -3? Good. No number does. There's not a single number that I can put in the absolute value that'll have an absolute value of -3. I can never have an absolute value that's negative. So in this case, we'd say no solution. There's no value of w that will ever be replaced into that would make that true. So now let's go to my last one. the negative absolute value of a is equal to -5. Well, once again, I would say, what value of a can I replace inside that absolute value sign that would result in 5, right? The absolute value of a would be 5, and then tag that negative on, that would give me the -5. All right. And in this case, you're absolutely right. It's a would equal -5 or 5. All right, so these were 4 examples that we can kind of look at and think about it logically and do it mentally. But let's kick it up a notch, right? We're not always going to get such easy absolute value equations. So before we begin, nice funny joke, I think at least, the absolute value of A is at a blood bank. That's impossible. I can't have a negative blood type. We know when we're dealing with absolute value, I can never have a negative value. All right, absolute value is representing the distance away from 0, and distance can never be negative. So let's take everything we know about absolute value now and let's apply it to some harder equations. Now here I have the absolute value of x minus 6 equals 4. Now once again, there's 2 different ways of looking at it. We can think about it in terms of distance, right? Absolute value is distance. We're saying the distance between a number and 6 is positive 4. So I'm thinking about what numbers have a distance between a number and 6 is 4 units apart. But another way that we can think about this is to really just think inside my absolute value. I can actually look at this like the absolute value of something is equal to 4. Now we know that something, right, inside that absolute value sign right here that I'm going to highlight, that can be 4 or it can be -4. So we can bring this idea back over to my equation. We're going to say that's something inside my absolute value sign. Well, in this case, the x minus 6, that expression can be equal to 4, or that expression must be equal to -4 in order for my original equation to hold true. So we're really just taking that expression inside the absolute value signs and we're saying, okay, whatever that is, it has to be equal to 4 or it has to be equal to -4. Now we're set with 2 different equations, no big deal. We can start to solve each of the equations out. We're going to start off with x minus 6 equals 4. Solve this. We add 6 on both sides. We're left with x equals 10. Okay, on the right-hand side, we're going to look at the second equation here. We're going to solve by adding 6 on both sides. And we're left with a final answer of x equals positive 2. Now we have 2 final solutions. We're saying x can equal 10 or x can equal 2. Let's actually pause and think about what that means. Remember, these are solutions to an equation. These are the only values out of all the numbers in the world that I should be able to plug back into my original equation and it should hold true. So I'm going to take a look here and I'm going to just mentally plug in 10 here. If I plug x for 10, 10 minus 6 is 4. The absolute value of 4 is 4. That one works. Let's look here. If I plug in x equals 2, 2 minus 6 is -4, and the absolute value of -4 is 4. That also works. So my final answer is x can equal 2 or 10. To write this nicely, I'm actually going to just write it in set notation, and we write it using curly braces, try your best, and we always put it in order numerically. I'm going to box this final answer. So in this case, this solution to an equation, there are 2 solutions to this absolute value equation. If we go back to this thinking over here on the right-hand side, well, if we go back and thinking about it in terms of absolute value, the distance between a number and 6 is 4 units. Well, the number 2 and 6 have a distance of 4, and the number 10 and 6 also have a distance of 4. All right, so a few different ways to think about this. All right, let's go to the next example. This also shows up in your notes so you can follow along as we go. We're looking here at the absolute value of x plus 8 equals 5. Once again, if you like to think about it in terms of absolute value being distance, we can say the distance between a number and -8 is 5 units. Otherwise, my personal favorite is to really think about it this way. We're saying the absolute value of something is equal to 5. So in my brain, I think about it like this. The absolute value of something is equal to 5. And I look at this question mark inside and say, what value must go inside those absolute value signs to make my answer equal 5? Well, it needs to be 5 or -5. So everything in red I do need to see on your paper. We're going to start with taking this equation. We're going to take the x plus 8. That quantity x plus 8 needs to be equal to 5. Or that entire expression x plus 8 needs to be equal to -5. From here, we just solve out each equation. We subtract 8 on both sides on the left-hand side. We're left with x is equal to -3. I do the same thing on the right-hand equation. All right, I subtract 8 on this side, and we're left with x is equal to -13. All right, we always check. What this means is that all the numbers in the world, the only values that should technically satisfy my original equation is -3 and -13. So let's plug in. If I plug in -3 for x, -3 plus 8 gives me that +5. The absolute value of +5 is 5. Good. That one works. Let's look here. If I plug in -13, -13 plus 8 gives me -5. The absolute value of -5 is 5. So that one also works. So my final answer, written in set notation, in numerical order, curly braces, -13, so it's the set of values, -13 and -3. And that's my final solutions. All right, how do we feel about that? Let's keep going. So what we're going to do for the rest of our notes is we're going to take a look at some more complex absolute value equations. Now, before we begin, these are some helpful hints that might help you as you're going through some harder absolute value equations. The first thing I always recommend is to isolate the absolute value expression first. Remember, just like order of operations, we always simplify that first. So we never distribute into the absolute value. We don't treat them as if like they're parentheses, right? Then I always look and I ask myself, is my absolute value expression equal to a negative? If so, we can just stop right there and say, it's impossible. Absolute value can never be negative. Say that to yourself a few times in your brain. Absolute value can never be negative, right? So if you have an absolute value expression equal to negative, something like x minus 7, absolute value of x minus 7 equals -10, well, we know that's impossible. No matter what value of x I place inside those absolute value signs, I can never have a distance of -10. So something like this on the right-hand side, right off the bat, we can stop and say, nope, no solution. However, if it's not equal to a negative, we're going to keep going. All right, and what we're going to do next is we're going to set the expression equal to the positive value and the negative value. We solve each of the cases just like we did for those first two examples. And then this is the kicker, we do have to check. We always have to check our answer because some of my solutions don't actually work. If it does satisfy my original equation, it's included in my solution set. If it does not satisfy my original equation, then it's actually called an extraneous solution. All right? So these are all on your notes on the right-hand side, so you can reference them as we're looking through some of these problems. Let's take a look at our first harder example. Over here, we have the absolute value of 3x plus 9 minus 10 equals -4. Now, my goal is still the same with solving any equation. My goal is to find the value of x or the values of x that will satisfy this equation, that will make it true. To solve an absolute value equation, the first thing I need to do is to isolate this entire absolute value expression. So I don't want to touch that yet. The first thing I'm going to do is I'm going to add 10 on both sides. To isolate that expression, I'm going to get rid of that constant. Oops, sorry. Plus 10, giant equal sign. All right, now I'm going to bring everything down. We have the absolute value of 3x plus 9, being careful as I'm writing it down to make sure that my absolute value signs don't look like number 1, is equal to 6. Now I've isolated my absolute value expression, and this looks just like those original problems we dealt with. We're looking at the absolute value of something is equal to 6. So from here, we're saying that expression, 3x plus 9, needs to equal 6, or 3x plus 9 needs to equal -6. And if you're getting confused with that, let's actually think about that logically. You don't need to write this on your paper where the arrow is, okay? But I'm saying the absolute value of something is equal to 6. That's true, right? That's possible. I can have a distance away from 0 of 6. So that question mark right here, that value inside this needs to be 6, or it has to be -6. And that's what we're doing over here. We're saying that expression inside my absolute value signs needs to be equal to 6 or -6. Once we set up both equations, we're now going to start to solve it. on the left-hand side, 3x plus 9 equals 6. I'm going to subtract 9 on both sides. I'm going to go through all these steps, just solve out that entire equation. 3x equals negative 3. Divide both sides by 3. And then my final answer here is x equals negative 1. On my right-hand equation, same idea. I'm going to subtract 9 on both sides. Going through the steps, 3x is equal to negative 6 minus 9 gives you negative 15. Divide both sides by 3. And then my final answer on this side is x equals negative 5. Now, before I go on, I have to check my answers. All right, so somewhere towards the right-hand side, we're going to start to check for extraneous solutions. I'm going to actually do this in a darker green. All right, so here's my check. So the first thing I'm going to check right here is I'm going to check for x equals negative 1. All right, and I'm going to see if this holds true. When I replace my original equation with x equals negative 1, does it hold true? So I have the absolute value of 3x plus 9, always doing it back into my original equation. As easy as it would be to do it any place else in your work, you might have made a mistake, so we always have to plug into the original, which is annoying, it's time consuming. But that's the only one we can guarantee is the correct equation. Minus 10, does that equal negative 4? So let's actually solve this out using order of ops. 3 times negative 1 is negative 3. Negative 3 plus 9 is positive 6. So I have the absolute value of 6 minus 10 equals negative 4. 6 minus 10 does equal negative 4. Negative 4 equals negative 4. So this first solution is true. So we know x equals negative 1 is a true solution. Let's check our next one. We have x equals negative 5. So we need to double check to make sure that when we plug in negative 5 back to my original equation, does it work? So once again, back to my original. 3 times negative 5 plus 9, evaluating it. Double checking that when I plug negative 5 back into my original, it holds true. 3 times negative 5 is negative 15. So I have negative 15 plus 9 minus 10. Does that equal negative 4? Let's see. Negative 15 plus 9 gives you absolute value of negative 6. Minus 10 equals negative 4. Absolute value of negative 6 is 6. I'm going to keep going until I have that true statement. Whew, all right, so this also works. So in this case, we've got two values for x that makes this equation true. My final answer, I'm going to write in set notation in numerical order, negative 5, negative 1. It's a set of values. I'm going to box or finally circle that final answer. All right, so we've solved our first more complex absolute value equation. Ready to try another one? Great. Let's take a look here. In number 2, we have 3 minus the absolute value of 6n plus 7 equals 40. So the same idea applies. We're asking ourselves what value of n will make this equation true. All right? And the first thing we want to do is we want to isolate our absolute value expression. And in order to do that, we want to get rid of that 3 and we want to get rid of that minus sign. So what do you think is my first step to isolating this equation, or the absolute value expression? Good, I should subtract that 3. So I'm going to do that on each side. From the left, I'm going to bring everything else down. We have the negative absolute value of 6n plus 7 is equal to 37. From here, I still need to get rid of my coefficient. In this case, I've got a negative 1. So I divide both sides by negative 1, just isolating that absolute value expression. So now I'm left with the absolute value of 6n plus 7 is equal to negative 37. And I'm going to pause here and I'm actually going to think about that. Can the absolute value, and this is what's going on in my brain right now, the absolute value of something be equal to negative 37? Good, it can't, right? We can never have a negative absolute value. Distance can never be negative. So once I have an expression, an absolute value expression equal to a negative, I know right off the bat, I'm done. All we simply write is no solution. Or no real solutions, actually. Okay? There's no value of n that will satisfy this equation. All right, so that's nice and easy, right? If we ever get something, the absolute value of something is negative, we can now do it, right? Absolute value can never be negative. All right, so now let's kick it up another notch. We've got something like number 3. The absolute value of 2x plus 12 is equal to 4x. Well, don't get alarmed with this. The same idea applies, right? We first want to isolate our absolute value expression. And in this case, it's already isolated, which is nice. So I'm simply saying the absolute value of something has to be equal to 4x. All right? Well, ignoring the value of x for a moment, we're going back to basics. The absolute value of something, whatever's inside my absolute value signs, can be equal to 4x, or it can be equal to negative 4x. All right, so we're going to take that same idea here, and we're going to apply it to my original problem. We're going to take that expression inside the absolute value signs, 2x plus 12, it can equal 4x, or the 2x plus 12 can equal negative 4x. All right, don't get alarmed by that. Then from here, we're just solving out each equation. We know at this point how to solve equations of variables on both sides. Now when I take a look at this left-hand side, lots of different options, but I'm going to subtract 2x. I'm going to get all my variables onto one side, all my numbers on the other. I'm left with 12 is equal to 2x. To solve for x, I divide both sides by 2. And I'm left with x equals 6. On the right-hand side, I'm going to do the same thing, solving. I'm going to move all my variables to one side. I'm left with 12 is equal to negative 6x. I divide both sides by my coefficient of negative 6, and I'm left with the answer of x equals negative 2. Now remember, we always have to check, right? We have two solutions here, but we're asking ourselves, if I plug 6 back into my original equation, will it hold true? And if I plug x equals negative 2 back into my original equation, will it hold true? So let's check. So on the side here in green, I'm going to do a check. The first one I'm going to check is x equals 6. I'm going to plug 6 in every time I see x back into my original equation. So I always write my original equation first. I'm going to replace x with 6. 2 times 6 plus 12 is equal to 4 times 6. Let's see if this holds true. The absolute value of 2 times 6 is 12, plus 12 equals 4 times 6 is 24. I can do the rest mentally. 12 plus 12 is 24. The absolute value 24 is 24. So we have 24 equals 24. So perfect. X equals 6 does work. Let's look at the next one. If I plug in x equals negative 2, let's see if that holds true. All right, so I'm going to take my original equation, 2 times negative 2 plus 12 equals 4 times negative 2. We're going to go through and actually solve it out. The absolute value of negative 4 plus 12, does that equal negative 8? I start to notice something funky here, right? The absolute value is equal to negative. I'm going to keep solving it out though. Negative 4 plus 12 gives me absolute value 8. Does that equal negative 8? Well, no, it doesn't. 8 does not equal negative 8. Okay? So in this case, this is what we call an extraneous solution. And I'm actually going to write this here. All I'm going to write is this is extraneous. In your notes, you might want to add in this is extraneous because it does not satisfy the equation. So my final answer, I go back here. Unfortunately, this is not a solution. Okay, I don't want to put an X because that gets a little confusing. But my final answer is just going to be 6. And that's my final solution. So when we look at examples like this, we're starting to notice that when we have a variable on the right-hand side and one of my solutions comes out to be negative, we're most likely dealing with extraneous solutions, right? I can never have an absolute value of something equal to negative. So once you're done with that, let's kick it up one more notch. So if I give you a problem like this, the absolute value of 5x minus 2 equals the absolute value of 5x plus 4. This one gets a little tricky, but definitely doable. We can solve this. We're going to simply do exactly what we've been doing. We're going to isolate one of my absolute values. So you're going to either choose this absolute value expression on the left-hand side, or this absolute value expression. I'm going to choose the absolute value of 5x minus 2. And I'm going to say this basically needs to equal the positive version of this and the negative version of this. Okay, I'm going to show you what it's going to look like. Since that expression in yellow is already isolated, I'm going to take 5x minus 2, and it needs to equal the positive version of this, which is 5x plus 4. The next equation I'm going to come up with is that 5x minus 2 needs to equal, and watch how I'm going to write this, the negative version of that. Now we have both of our equations. We're going to go through the process of solving them. On the left-hand side, I'm going to move all my variables first. Now remember, that's going to look a little different for each of us. But I like to move my variables first, and I'm left with negative 2 equals 4, which is not true. When we have a false statement, what does that tell us? Good, no solution. So when I had it equal to the positive version, there was no value of x that will satisfy it. That doesn't mean there's no solution overall. We still have to go through and solve the other side. So the first step I'm going to do, distribute that negative 1. That gives me negative 5x minus 4. The next thing I'm going to do is I'm going to move all my variables onto one side. I'm going to add 5x on both sides. Now your work might look a little differently than mine here with your inverse operations, but I'm left with 10x minus 2 equals negative 4. The next thing I'm going to do is I'm going to add 2 on both sides. I'm left with, let me be consistent with my colors, 10x equals negative 2. What do I do next? Good, I divide by 10. And I'm left with x is equal to negative 2 over 10. I'm going to simplify that, negative 1/5. All right, so we have something here that is equal to a value. We still have to check. So on the side here in green, I'm going to do a little check step. And we're going to check for x equals negative 1/5. So you know the drill. Start with your original equation. 5x, absolute value of 5x minus 2, does that equal to the absolute value of 5x plus 4? We're going to replace x with negative 1/5. Don't get alarmed with the fractions. You're going to see that they simplify out nice and easy. Equals 5 times negative 1/5 plus 4. All right, on the left-hand side, 5 times negative 1/5, what does that give me? Good, negative 1, so I'm going to bring down negative 1 minus 2. Equals 5 times negative 1/5, that's negative 1. Negative 1 plus 4. So the absolute value of negative 1 minus 2, that gives me the absolute value of negative 3, equals negative 1 plus 4 is 3, so the absolute value of 3. And the absolute value of negative 3 is 3, absolute value of 3 is 3. This holds true. So I go back here, x equals negative 1/5 does satisfy my original equation. So my final answer in set notation is negative 1/5. All right, we just did a lot. I'm going to go back really quickly before you try some out on your own. We talked about absolute value, right? Absolute value being the distance a number is from 0. We looked at some numerical expressions involving absolute value. We then looked at how we can actually transfer that idea to understanding how to solve for x in a solution, in an equation, right? We can apply what we know about absolute value to see if maybe I have one solution, something like this. Sometimes I have 2 solutions. Sometimes I have no solution, right, when an absolute value is equal to a negative. We then looked at a simple absolute value expression, right? We talked about how we can split that expression up into the positive value and the negative value. We then looked at more complex absolute value equations, and we talked about the importance of first isolating my absolute value expression that's highlighted in bright green, right? And then splitting it up into 2 different sections, all right? We always talked about we also reviewed the importance of checking to make sure that each of the answers actually satisfies my original equation. We looked at examples that came out to be no solution. Anytime you have an absolute value equal to a negative, those are nice values. We know to stop right there, and we can simply write no real solution. Sorry, I should have wrote no real. All right. And then we looked at more examples in which maybe sometimes they both solved out to be numbers, but then one of them turned out to be extraneous. So what you're going to do right now is you're going to try out these 3 examples. remembering to isolate the absolute value first. When you're done with all three, you're going to switch over to a pen and you're going to unpause the video and you're going to check your answers. So go ahead when you're ready, you're going to pause the video, try out example A, B, and C, and then when you're ready, you're going to unpause the video and you're going to look at the solutions. All right, at this point, I think hopefully you've checked A, B, and C. You've tried A, B, and C out, and then you've also checked for extraneous solutions. Let's take a look. In example A, you should have first solved by subtracting 2 on both sides. You are then left with -5 times the absolute value of 5m minus 5 equals -75. You're still working on isolating that expression, absolute value of 5m minus 5, so you divide both sides by -5, and you're left with what I'm going to highlight in red, which is that pivotal point, the absolute value of 5m minus 5 equals 15. Now we know that's possible. The absolute value of something can be 15. So I split it up in both sides. We're left with -2 and 4, and when you check for extraneous, both work. Neither of those are extraneous solutions, so my final answer is -2 and 4. Looking at example B, this one was a little tricky. You're going to notice here that I actually took this expression and equaled it to the positive version, 2x plus 5, and I set it equal to the negative version. I solved both of them out. Neither of them were extraneous, so my final answer was 7/5 and 17. Keeping that as an improper fraction, simplest form. If you turn it into a mixed number, that's fine too. In example C, once again, set them equal to the positive and the negative. I noticed that both of them were extraneous. Actually, hold on one second. All right. Oh, no, x equals 1 was extraneous, so my final answer is x equals -5. Oh, no, both of them are extraneous. I'm sorry. I just totally messed up there. Yep. So that when you check them, they're both extraneous. So my final answer is no solution. All right. My answer got cut off. All right. So we've done a lot of work with absolute value equations. Hopefully this helped. Thank you guys for watching. Don't forget to like and subscribe.